Hi students, so now we are still on example 5.1. So we're trying to find, now we are at question F. We want to sketch the flow profiles that exist in the channel. Okay, so since you want to know the flow profile, so we would like to know whether it's m for mile or whether it's steep, but in this case we will have mile reach. Okay, that's why I put this table just for you to understand what I'm talking about. Okay, so let's draw the channel profile. So we have a channel with the slope of 0.005. So first you can draw the critical depth. So the critical depth is always parallel with the bottom slope. Okay, so this is critical depth. So this is YC, which is equals to 0.97. Okay, 97 meters. And we know that y normal, which is from question A, so it's equals to 1.26 meters. Okay, so 1.26 meters is obviously above the YC. Okay, so when YO y normal is above YC, so most probably this flow is mile. Okay, because you see here y naught is more than YC. Y naught is always more than YC. And also in the third case, M3, Y naught is more than YC. So we know that the profile will be mile, but we do not know yet which one or two or three. Okay, so let's just draw this Y naught here. Is equals to 1.26. So you know that okay, so we have a gate. The height of the gate is given as 0.5. I mean the space here is Y gate. Okay, Y gate. Okay, so this is 0.5 meter. Okay, so just after the Y gate, there is a flow here going up. We already measure it. We call it as Y conjugate. Okay, and then there is a hydraulic jump. The hydraulic jump will go back to the normal depth. So we calculated the conjugate, Y conjugate here from question E. Okay, Y conjugate is equals to 0.73. Okay, so okay, this is the first situation. We also calculated Y immediately before the gate. So here, okay, so this is from question D. Okay, from question D we know that this is the Y is equals to 2. Let me check, 2.44 if I'm not mistaken. Yes, 2.24. 2.24. Okay, so we call this alternate depth for the Y gate. Okay, because energy is conserved at this Lewis gate. And here the energy is 2.33 meter. Okay, so but then you know that before this depth we have the normal depth. Okay, so the normal depth is this one, yeah. Okay, this one. I would like to change the ink. Okay, we know that this is normal depth. It's written there that the normal depth, the upstream and downstream boundary condition are normal depth. Okay, it's written in the question. Okay, always have trouble to find this. Okay, so the upstream and downstream boundary condition are normal depth. So this is the upstream and this is the downstream. So here you also have y normal depth as 1.26 meter. But what happened here? Y just before the sluice gate is 2.24. So you know that the flow is going up. Okay? So in this case, we want to know this section. So we know that this is M, but we are not sure which M it is. So in this case, y naught is 1.26. So, and this y is 2.24. So we know that y 2.24 sluice, okay, is bigger than the y naught normal depth, and normal depth is bigger than yc. Okay, so this condition meets M1 profile. So the profile here, this is then M1. Okay, so you have another profile which is here. It is also going up. Okay, so the y that we are interested with is the y conjugate. So this will determine the type of M we have here. Okay, so you know that y conjugate is less than yc. So y is less than yc. But yc is less than normal depth. Why not? Okay, so which condition this profile meets? So this meets with the third M3. With the M3 condition. So you know that the profile here is M3. Okay. The final question wants us to find the energy of the plot. It is actually a very easy one. Okay, maybe I will show you in the final video. I will stop first here. Thank you.